Why are we going back to the moon? This is the question I was eager to find the answer to after I saw this announcement from the NASA.
Make the next giant leap and return American astronauts to the moon.
And I found some answers I was not expecting at all, because what has been planned for the moon has the potential to reshape life here on Earth. But before that, let's play a guessing game. What do you think costs more? Making a Hollywood movie or landing a rover on the moon? A decade ago, this would have been a ridiculous question. But in 2024, a lunar mission might actually be cheaper. Let me explain. In 1969, it took 400,000 people, 4% of the US federal budget, which is around 280 billions of today's dollars, to put Neil Armstrong on the moon. That is enough money to make 70 Avatar sequels. So yes, we spent about the budget of 70 Avatar movies just to pick up some space rocks. But now it is totally different story. The cost of sending payloads to space has become way cheaper due to the entry of private companies like SpaceX and Blue Origin. Cheaper rockets are just the beginning of the story. We are seeing something far bigger. The transformation of Moon from a government project into potentially the biggest business opportunity in human history. Okay, imagine this. You need to send your laptop, which is around 1 kilogram, to the moon. During the Apollo era, this would have cost you about $28 million. That is enough money to buy a mansion in Beverly Hills just for sending your laptop to space. This might make you wonder, why was it so expensive? The short answer is, we were dumb. Think about this. Imagine if every time you flew somewhere, the airline built a brand new plane, used it once, and then dropped it into the ocean. Sounds crazy, right? But that is exactly what we had been doing with rockets until now. No wonder space was expensive. Check out this video for more info. Take a look at this video. See this? This was the Canon event which changed everything. Instead of throwing away billions of dollars of hardware after each launch, companies like SpaceX can now land their rockets and use them again, and again, and again. This makes the savings during each launch add up, which ultimately makes the rocket launches cheaper in the long run. But here is where things get really interesting. The cheaper launches created a snowball effect. More launches meant more experience. More experience meant better technology. Better technology meant even lower costs. And suddenly, missions that once required the resources of an entire nation become possible for private companies. Look at what happened just recently. India's Chandrayaan-3 mission landed on the moon's south pole for just $75 million. That is less than the budget of Thor: Love and Thunder. How cool is that? Japan's SLIM Slim mission cost around 18 billion yen, which is equivalent to $121 million. This shows us even smaller space agencies now can reach the moon with precision and low budget. But here is the million-dollar question, or should I say trillion-dollar question. Why are all these companies and countries suddenly so interested in the moon? Is it just because it is cheaper to get there? Or something is up there that is worth more than all the money we have spent getting back? To answer that, we need to talk about what is actually on the moon. Take a look at your smartphone for a second. That smartphone is made up of various components. To make some of those components, we need a few rare materials. These materials are very rare on Earth. They are literally called rare earth elements. Now, here is something wild. Everything you need to make that device is sitting on the moon right now. And this is just the beginning. What if I told you that moon may have a solution to Earth's energy crisis? Sounds crazy, right? Let me explain. Most people think of the moon as a barren and useless rock. And honestly, they were right until now. For most of the human history, that is exactly what it was. But now we have come to realize we have been looking at the moon all wrong. It is not a rock, it is a treasure chest. Let's start with something you will never expect to find on the moon. Water. Not a few frozen puddles. We are talking about 600 million tons of ice hidden in permanently shadowed craters near the lunar poles. Okay, you might be thinking, what is so exciting about the ice? Well, think of it like this. Imagine you are planning a road trip across the country. You would need to pack food, water, and fuel, right? Now imagine if you could make your fuel from the ice you find along the way. That is exactly what we can do on the moon. Split that H2O into hydrogen and oxygen, and suddenly you have got rocket fuel. It is like having a cosmic gas station where you can fill up your rockets. But water is just the starter here. Let me introduce you to something that would change our life as we know it. Helium-3. For billions of years, the moon has been collecting this rare isotope from solar winds like a cosmic saving account. On Earth, helium-3 is so rare it's worth about $15,000 per gram. Not kilogram, but gram. But the moon? It has over 1 million metric tons just sitting there. It is like finding out your grandmother's computer is full of Bitcoin from 2009. The moon has been collecting this stuff for billions of years and we are just checking the balance now. Just 44 tons of this helium-3 could power the entire United States for a year. No pollution, no radioactive waste, just clean, nearly limitless energy. How cool is that? And the moon has enough stock to power our entire planet for 10,000 years. Talk about stockpiles. When you add it all up, the water, the helium-3, the rare earth elements, we are looking at resources worth trillions of dollars. It is like discovering a new continent, except this one is floating right above our heads. Okay, you might think this is some theoretical nonsense, but see this. We are taking the first steps towards securing these resources. Right now, NASA's Viper rover is getting ready to launch in 2025 to map these resources. This rover will create detailed map of potential resources, which is crucial for future human exploration and habitation on the moon. This helps us understand where water and other materials can be harvested for sustainable human presence. China's Chang'e 5 mission has already confirmed high concentration of rare earth elements in their sample. So, we are not just exploring anymore, we are prospecting. Mining on the moon is like playing Minecraft in hardcore mode. No oxygen, extreme temperatures, and if you fall, you might float away. But hey, at least there are no creepers. So what is this all about? Are we just going back for the resources of the moon? Well, space exploration has come a long way since the days of planting flags on the moon. Today, the lunar surface is becoming a launch pad for humanity's future in space. This new era of exploration is vastly different from the space race of 1960s, which was driven by national pride and competition. Now, it is about establishing a sustainable presence on the moon and preparing for even greater adventures beyond. In 2022, NASA's Artemis 1 mission circled the moon with SLS spacecraft. It was one of the powerful rockets we have ever built. But this time, they did not do it alone. Private companies are now essential partners in these missions. For the first time in human history, we are not just visiting space, we are moving in. The technologies being developed aren't just getting there, they're about staying there. How do you shield against radiation in deep space? Can you 3D print spare parts using lunar dust? These are not just engineering problems, they are the questions that will determine whether humanity can truly become a spacefaring species. Right now, we are watching this unfold in real time. SpaceX is testing Starship. The Starship is not just another spacecraft. It is potentially humanity's first true interplanetary vehicle. Blue Origin is developing their Blue Moon lander. China and Russia are planning their own lunar base. Even countries with small space agencies like India and Japan are joining the race. But here's what makes this truly different from the 1960s. These are not competing programs. They are potential pieces of humanity's first real presence beyond Earth. It is like when a new Starbucks opens. Suddenly everyone needs to be there. Except instead of a coffee, it's a $1 trillion resource. Every technology we develop for the moon, every problem we solve, brings us one step closer to Mars and beyond. We are not just going to the moon to say we did it. We are going there to learn how to live there. And in doing so, we might just figure out how to live anywhere in the solar system. Look up at the moon tonight. It looks exactly the same as it did when your grandparents looked at it, or when Neil Armstrong first walked on it. But something fundamental has changed. We are not just going back to plant flags or collect rocks. We are going back to stay. In the coming decades, you might look up at night to see tiny points of light that are not stars, but the glow of human activity. Lunar bases, mining operations, research stations, maybe even hotels, who knows? Think about this. Your grandparents watched humans walk on the moon for the first time. Your children might watch humans build cities there. And all of this is happening because we finally figured out that moon is not just a satellite. It is humanity's first stepping stone to the stars. The next gold rush won't be in California. It won't be even on Earth. It is happening 384,400 kilometers above our head. And unlike the gold rushes of the past, this one could benefit every person on Earth. From the energy we use to devices we depend on to the very way we think about humanity's place in the cosmos. The only one question is, when we look back at this moment from our lunar cities, will we remember it as the time we finally got serious about space? Or just another small step that led to humanity's greatest leap? Thank you for watching.